In this video, we're going to talk about perpendicular bisector of a line. Our objective is going to be to find a line y is equal to mx plus c, this purple line, such that your line is going to be perpendicular to 2 points. So you're going to have the points A and B, and you're going to find a line that's perpendicular to the line AB. And then the word bisector stands for two, bi. So it means that it's going to be crossing between A and B exactly in the middle. So this point here is going to be referred to as the midpoint between the points A and B. So we're looking for a straight line that passes through the middle of AB and is perpendicular to AB. So that's going to be our objective for today's lesson. First, we're going to need to find out how to calculate the midpoint of any 2 points. So in order to do the midpoint of any 2 points, you're going to use the formula which is in your formula booklet, and it goes, you're adding the two x coordinates together, and you're dividing it by 2 to find the x coordinate, and you're adding the two y coordinates together, and then you're dividing it by 2 to find the y coordinates. And this formula is given to you in the formula booklet. Okay, the 4 steps that you're going to be doing in order to find the equation of the perpendicular bisector. First, you're going to find the midpoint between points A and B. Next, you're going to find the slope between the 2 points. So what is the slope of the line AB? Once you know the slope of the line AB, then you're going to find the negative reciprocal of that slope in order to get the slope of the line, which is the perpendicular bisector, the line we're looking for. Now we're going to have the slope of our line, and we're going to have a point which is on our line. So using those two pieces of information, we'll be able to find what is the equation of our perpendicular bisector. Let's try an example. Example 1. Find the equation of the perpendicular bisector AB given that A is negative 1, 0 and B is 3, 4. So I did a little graph. A is going to be the point which is here, which is negative 1, 0, while B is the point which is 3, 4. Now our objective is going to be to find the perpendicular bisector of AB. So it's going to be a line that is going to be exactly halfway between AB, somewhere here. We're going to find what this exact coordinate is, and it's going to be a straight line that is perpendicular to AB. So this is going to be the objective of this question. Our first step is let's calculate what the midpoint is. So the midpoint between A and B, we can use the formula which says we're adding the two x coordinates, so 3 plus negative 1, and we're dividing it by 2, and we're adding the y coordinates, dividing it by 2. So our midpoint is going to be the coordinate 1 and 2. So this point here is actually the coordinate 1 and 2. Our second step is going to be to find the slope of the line AB. In order to find the slope of the line AB, we're using the slope formula which is given to us in our formula booklet. So we're subtracting the y's, and then we're dividing it by subtracting the x's and making sure that it's 3 minus negative 1. So we have 4 divided by 4. The slope is 1. So since we know the slope of AB, now we can do our third step, which is to find the slope of our perpendicular bisector. I'm going to short form that to PB. So the slope of our perpendicular bisector is going to be the negative reciprocal of the slope AB. So if this one is 1, then that means that ours is going to be negative 1. So now we have the slope of our line. So let me highlight this. We have the slope of our line, and we have a point on our line. So we're ready to find the actual equation of our perpendicular bisector. Our slope is negative 1, so our perpendicular bisector will have the equation y is equal to negative 1x, or just negative x, plus c. I need to find out what this c is, so I replace my x and y coordinate into my equation. And I find that c is equal to 3. Therefore, the equation of my perpendicular bisector is y is equal to negative x plus c. Sometimes questions will ask, what is the shortest distance from a point to a line? When these types of questions are asked, we need to know that the shortest distance from any point to a straight line is by creating a perpendicular line. So going across this line that's red is going to be the shortest distance if, when we get to the point on the line, it creates a 90-degree angle. So this is going to be really important to understand when we're answering more application type questions. The shortest point from a point to a straight line is by creating a 90-degree angle. A robot vacuum cleaner is located at point A, which is 410. Let me label that on my diagram. It currently cleans by moving along a straight line from A to point B, which is 19.5. The robot charging station is located at point E at 6.3. The vacuum cleaner will have to return to point E to recharge before it reaches point B. It is programmed so that it will return to point E at point D, which is on AB, such that ED is the shortest distance from E to line AB. Find the coordinate of D. We have a situation here that we're looking for the shortest distance between a point and a line. Now, the shortest distance between a point and a line is going to be the distance that is perpendicular to the line. So I'm going to go from E, I'm going to get to point D, and this line DE is going to create a perpendicular angle. So it's going to be perpendicular to the line AB. And we're going to need to find this point D. Now, the first step that we can do is we can find what is the slope of the line AB. Well, the slope of the line AB, we can use our formula, is going to be 10 minus 5 divided by 4 minus 19. So we're going to have 5 minus negative 15. So the slope, if we simplify this further, is going to be negative 1 over 3. Next, if the slope of AB is negative 1 over 3, then I can find the slope of the line DE. The slope of the line DE is going to be negative reciprocal. So that means if the first one is negative, then mine is going to be positive, and then I'm going to have to flip the fraction. So I'm going to have a slope which is 3 over 1, or simply 3. Now, we have the slope of the line DE, and we do have the coordinate of point E. So next, I can find what is the equation of the line DE. So find the equation of the line DE. So my equation is going to be y is equal to 3x plus c. And then in order to find c, I'm going to replace it by the coordinate of E. So we're going to have 3 is equal to 3 times 6 plus c. 3 is equal to 18 plus c. We're going to subtract 18 on both sides. And we're left with negative 15 is equal to c. So y is going to be equal to 3x minus 15. Now we're looking for point D. There's a few ways that we can do this, but one of the ways we can find point D is that it's the intersection point between the lines AB and the line DE. I have the line DE, I have this one here. However, I'm still needing to find the line AB. So for my fourth step, I'm going to find the line AB. The line AB, I know it has a slope of negative 1/3, so it's going to be negative 1/3 x plus c. And then I can replace either point A or point B into this equation. And I'm going to get negative 1/3 times 4 plus c. When we simplify this, we're going to get that we have 10 is equal to negative 4 over 3 plus c. So we're going to be adding 4 over 3 on both sides. So 10 plus 4 over 3, that is our value of c. So if you put this into your calculator, you should get 11.33333, but we can round to just 11.3. The equation of the line is negative 1 over 3x plus 11.3. Now take out your calculators and we are going to find the point of intersection between our two lines. So in our calculators, we're ready to put in our two functions. So I'm going to go on y is equal to, I have 3x minus 15. That's the first equation. And my second equation, I can put a fraction here, negative 1 over 3 times x plus 11.33333. When I graph this, I can see the intersection point on the graph. Now my window is just at a standard window, so when you click on zoom 6, this was the window that I had. In order to find the intersection point, second function trace, and the fifth option is intersect. It asks us what is the first curve. I say yes to that. Second curve, it is the red one. And then yes, I just click enter as well because there's only one point of intersection. Therefore, we get the value for our intersection point, which happens, so fifth step, intersection point. Our intersection point is 7.899. So if you round this, you would actually get 7.9. And 8.6999. So if you round this, you get 8.7. And this is going to be the intersection point. Therefore, this is our point D. And that was what we were looking for in our question.